Hello, geometry. This is 5.7, using congruent triangles. So remember, congruent triangles, whenever they want that, are methods that we have are side, angle, side. That makes congruent triangles. Angle, side, angle. Angle, angle, side. Side, side, side. And if it's a right triangle, you can use hypotenuse, leg. So these are going to show up throughout the assignment today, and using those to prove that we have triangles that are congruent. So on page 153, we have a figure here. This surveyor is trying to measure the width of this river. So we have two triangles. AC is congruent to CD. And notice it's a right triangle. Whenever you see a right triangle, you can think hypotenuse, leg. And then you have a line drawn from this point over to here, over to E. So these two triangles, study the figure, explain how the surveyor can find the width of the river. We want to find this length right here. Well, corresponding parts make that equal to this length. So DE has to be the same as BA. So we have to ask ourselves, do we have enough information? I just realized my picture's not on there. Not that you really need to see me, but I think it makes it a little bit more personable. There we go. Hi. Okay. So we have BA and DE. We want to know, would those be congruent? Are these congruent triangles? So let's check. We have a side. We have an angle. It's a right angle, so I check hypotenuse, leg. Well, I have a leg that's congruent. AC is congruent to DC. That's a leg. But I don't know if these hypotenuses are congruent. What's the plural of hypotenuse? Okay, look that up and tell me. There's your trivia for today. Now remember, right here we have intersecting lines. So that makes this angle congruent to this angle. So you have vertical angles. And that gives us angle, side, angle. The side is included between the two angles. So we could say, since triangle ABC is congruent to triangle ABC, would go DEC. AB, the length from A to B, would equal the length from D to E because they are corresponding parts. They're corresponding parts of congruent triangles. Okay, sometimes they add that, corresponding parts of congruent triangles. Okay, so since the two triangles are congruent, these are corresponding parts. If you can figure out this hypotenuse correctly, this length right here, measuring this length, would give you the length of the river. Now that's what they refer to as using congruent triangles to make an indirect measurement. You want to measure this, but you can't directly measure it. So you indirectly measure this, knowing that it implies to that corresponds to that distance across there. Okay. So on page 154, again here you have two triangles. They're right triangles. They both share this side right here. And so they're going to say this angle is congruent. If you read through this, he's standing on the bank of a river, lowered his visor cap until it was the furthest thing visible was the edge of the bank. He then turned and noted the point on his side that was in line with the tip. So he looked out, and then he looked down until he could just put it on the other side of the river, and then he turned and kept that same angle. So that's called an angle of depression, because it went down. Advanced math and trigonometry, we'll get into that more. Okay, so that's an angle right there. So we have angle, side, angle. That measurement would be the same sort of thing. So here's your vocab. Congruent figures, we know that's the same size, same shape. Same size, same shape. Corresponding parts, we already know that. So that's the parts of congruent figures. That would overlap. Construction, we're not going to do that virtually. We may try to do some constructions in class someday, something a little different. But constructions is when you make making things with only a a compass and a straight edge, not even a ruler, so you can't measure lengths. But how can you make a perfect square or equilateral triangle and some of those things, angle bisectors, using a protractor and a compass. So a construction is creating, we're going to say, perfect geometric objects using only a compass and straight edge. Compass and straight edge. So the majority of your questions today here, explain how to prove that the statement is true. Okay, so they're giving us here, explain how to prove that the statement is true. Remember our congruent statements. Side, angle, side, 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 angle, side, angle, 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 side, and hypotenuse, leg. There is no side, side, angle. No profanity in geometry. Okay, so explain how to prove that the statement is true. So we want to prove that UV is congruent to XV. What you need to answer is, how are the triangles congruent? Okay, which of the 5 methods here prove that the triangles are congruent? So they want UV to match up with XV. Okay, now these two triangles, here's an angle, angle T corresponds with angle W. The sides are congruent, and here we have intersecting lines again. That makes vertical angles. So we have angle, side, angle. So we're going to write a congruent statement. We're going to write a congruent statement. So triangle TUV is congruent to triangle. So T matches up with W, U matches up with X, and V would be the vertex angle there. So make sure the order there is correct. The order is important. Okay. So we're ready for our conclusion, which is UV is congruent to XV. And the reason is they are corresponding parts of congruent, we're going to shorthand here, triangles. Corresponding parts of congruent triangles. Okay. So step number 2, or problem number 2, TS is congruent to VR. TS is congruent to VR. So we want to prove that this side is congruent to this side. So we have side, side, angle. That's this one. Side, side, angle, which, remember, side, side, angle, no profanity in geometry. Look at it backwards if you don't figure that one out. But we do have a right triangle, so the one we want to look for is hypotenuse, leg. So the hypotenuse here matches the hypotenuse here. That's the longest one, opposite the 90-degree angle. And then you have a leg congruent. So let's write our congruent statement. Triangle RST is congruent to triangle. So R would go to U, URV. Make sure you go in the right order. And a hypotenuse leg theorem, congruence theorem. So since those are congruent, notice TS is right there and RV is right there. So our TS is congruent to VR because they're corresponding parts of congruent triangles.
You have to admit it?
I did.
What the heck? I reloaded like 10 times.
Yeah.
Okay, all right.
Okay. Let me check. Okay, sorry about that. Okay, last one, angle JLK. JLK, they want to know this angle and MLN, this angle. Are they congruent? Okay, here's our triangles. Which congruence theorem do we have? Looks like we have two sets of sides. So we have a side, and we have an angle. The angle is between the two sides. This angle is being formed by the two sides. That is side, angle, side. Side, angle, side. So let's write our congruence theorem. Triangle JKL is congruent to triangle MNL by side, angle, side. And now you can write your given. Angle JLK is congruent to angle MLN, and that's corresponding parts of congruent triangles. There you go. Corresponding parts of congruent triangles. Okay, the final thing is write a plan to prove angle 1 is congruent to angle 2. They're going to give you an object. They want you to prove, okay, how can I prove that angle 2 up here is congruent to angle 1 down here? And it's kind of along the same lines, just a more in-depth description of what we have here. So I see I have two triangles here. So angle 2 is part of this triangle. Angle 1 is part of the triangle on the right. I know that this angle up here would correspond to this one. So this angle I would correspond to angle G. And here's a side, so here's angle side, and look here, there are congruent triangles. Okay, so we have two ways to do this. We know that angle FJG has to be congruent to angle HJI because they're vertical angles. And so you have a triangle here that has two sets of congruent angles. And we had a theorem a little while ago that said if you have two sets of congruent angles, the third angle has to be congruent as well. Okay, so you can do that as a third angle theorem. Angle 1 is congruent to angle 2. That's the third angle theorem. Where it pays to go back and study your theorems. Or you have angle side angle, which I think is more the way the textbook was wanting us to do this problem. You have angle side angle. So we could say angle FJG is congruent to angle FJG, would be HJI, because of the angle side angle theorem. Okay, see the side is between the two angles that you know. And then we could say angle 1 is congruent to angle 2. That would be corresponding parts of congruent triangles. Okay, so a couple different ways you can take that plan. Again, remember the context of what we're working with this, because they're wanting us to use some of those congruence theorems, so my guess is they're wanting you to go that route. Okay, we're going to do number 5 and call that good. How would we prove angle 1 is congruent to angle 2? So as I was looking this over, I saw the smaller triangles, BEC and DEC. I was like, oh, if I can prove those triangles are congruent, then those would be your corresponding parts. So I have BC is congruent to CD, and EC is congruent to EC. They share that side. So I have two sides, but I don't know if BE is congruent to ED, and I don't know anything about the angles in there. Okay? So I don't have enough information to show that the smaller triangles are congruent to each other. So then I have to look at the bigger one. I notice these tick marks up here. So if I look at triangle ABC, this big one here, and triangle ADC, I'm like, oh, they have those two sides congruent, they share a side. So I know triangle ABC has to be congruent to triangle ADC by the side-side-side congruence theorem. So what that tells me then is these angles do have to be congruent. So these are corresponding parts down here. Okay, those triangles don't use angle 1 and angle 2. But these angles here are common to both triangles. So the measure of angle BCE has to equal the measure of angle DCE. Or you take the measures off and you can say they're congruent. And that's because these are corresponding parts of congruent triangles. So now we have our information that we need. these two triangles here, you have an angle, you have side angle side because they share that. Okay? So and you can write this out more as a paragraph with sentences, as I would prove that these two triangles are congruent. That means these angles are congruent, and then these are going to be your corresponding parts. Okay. So we have these share a side. So we know we share the side EC. That's common to both. So triangle BCE has to be congruent to triangle BCE DCE, and that's side angle side congruence theorem. And since these two triangles are congruent, angle 1 is congruent to angle 2 because they're corresponding parts of congruent triangles. Not angles, triangles. Okay, so in your assignment today, that's what you're seeing. You have a little vocab there at the beginning. Explain how to prove that the statement is true. So these questions deal with which congruence theorem can you use. Write a plan that the triangles are congruent. You're going to have question number 11 down here. And then you just have a few application ones that are kind of fun. Explain how to find the distance across the canyon. That's similar to our example at the beginning. No one's seen this in my classroom. That looks familiar. Can answer those questions. And then something with the Jamaican flag down there. Okay. So if you want to check out question 20 in the textbook, there's one with the Bermuda Triangle. It's kind of cool. I didn't assign that one, though. Okay, so that's it for section 7. Okay, we'll see you in class.